Welcome back to part 2 of Module 8, Lesson 1, where we're continuing our study of proportional relationships and slope. Here we got a little disco dancer going on. It says an online music store charges $3.75 for purchasing 3 songs. Assume the cost Y in dollars is going to be proportional to the number of songs purchased X. Graph this relationship on a coordinate plane and then find and interpret the slope. So, with that said, we know that 3 songs is going to cost $3.75. That means if you divide $3.75 by 3, 1 song is going to equal to $1.25. That gives us a unit rate of $1.25 per song. From here, we can take and move a little bit forward where we can do a table. That means 2 songs is going to be $2.50. That means 4 songs, that's going to end up being $5. Keep moving forward from there. And now we get to graph the ordered pairs that were created there. And you can see they're listed up here along the top section. That's the ordered pairs we're graphing. So 1 song was $1.25. We're going to take and grab our dot and we'll put 1 and 1.25. 2 songs was going to be $2.50. 3 songs was going to be $3.75. And 4 songs, that was going to end up being $5. You can connect those points with a line. You cannot buy half a song, so it's not going to get a solid line. You're going to get a broken line to indicate that you have to buy whole songs there. And you can see that information created a line. It is a linear relationship, so we have a constant rate of change, also known as a slope. Moving forward with this problem, the unit rate is also going to be the slope of the line. So what was the cost per song? It was $1.25 for every song purchased. So your constant rate of change is going to be that same $1.25. And the constant rate of change, that's also going to be the slope. You can see that when you're doing this, you have a constant rise over run relationship. Now, if you scroll way down here to the bottom and read the fine little print that they give us, you can see that they're saying that the slope of the line is going to be 1.25 to 1, also known as 1.25, and that means that the cost per song is going to be $1.25. And it's going to be your turn again. Go ahead and pause the video and work on solving this problem on your own. The 8th grade band is having an ice skating party. It costs $40 for 4 students, so that's going to be a ratio, $40 for 4 students to attend. Assume the cost Y is proportional to the number of students X. That means we could take and simplify that down to get a unit rate, not 4, 10, divided by 4 over 4, and that would mean that the cost is going to be $10 for every 1 student. Now with that information, we can jump back over to the problem page and we can start creating ourselves a graph. That means that, of course, if no students attended, that would be 0 cost, and if 1 student attended, that's going to be a cost of 10, and from there it's going to be a dotted line continuing up from that. It's a dotted line because can half a student ice skate? That'd get pretty messy on the ice, guys. I'm just saying, gross, okay? So from there, you've got your slope that you can see is a straight line, and we can say from there the slope of the line is going to be, set it up as a fraction, 10 over 1, except, and that means it costs $10 per student, and it checks. Easy math, anybody can do this stuff. Next, we are going to compare proportional relationships. You can use tables, graphs, words, or even equations to represent and compare proportional relationships. In an equation of a proportional relationship, y is equal to mx. M is going to represent your slope or your unit rate. It's the same thing. In a table, the slope is going to be the constant rate of change, also known as a unit rate. In a graph, the unit rate or slope is once again going to be your constant rate of change, and it's going to be represented by the constant ratio of y divided by x. You can also find the unit rate from 0.1r, where r is going to be your unit rate, and we will hopefully just explain that last part a little bit more, because that sounds kind of confusing, doesn't it? In words, the cost y is directly proportional to the number of breakfast x. In an equation, you have y is equal to 2 times x, where 2 is going to be your slope or your constant rate of change or your unit rate. And then down here for a table, wow, got to scroll way down to see that table. You can see for every change in x of $1, you get a change, or one breakfast, you get a change in y of $2. That shows your constant rate of change in your table. And finally, on a graph, you can see it creates a straight line, and you have a constant rise to run, rise to run 1, rise to run 1, rise to run 1, all the way across through the process. In example 4, they have us comparing proportional relationships again. They say the distance y in miles can be covered by a rabbit in x hours can be represented by the equation y is equal to 35x. And there is no way that rabbit's going to run 35 miles in an hour. I'm just saying, it's not going to happen. It would die of a heart attack. Anyhow, the distance that can be covered by a grizzly bear is going to be shown on the graph. So here we want to find out which animal is going to be faster. So you can see that right here where you have your grizzly bear, he has a speed of 30 miles in 1 hour compared to your rabbit that was 35 to 1 or 35 miles in 1 hour. That means that little rabbit, he's going to be a little bit quicker than that grizzly bear is going to be. But let's actually dig into it and prove it some. In the equation, y equals 35x, your slope is unit rate is a coefficient of x, so the unit rate is going to be 35 miles or 35 to 1. 35 miles per hour, I should say. And then the graph of the grizzly bear, you have y divided by x, or you can use 0.1r, and that's 0.1 right there, and the rate R30 is going to be 30 miles per hour there. Or you could take and do the rise over run, 30 divided by 1, or you could do just pick any 2 points, 60 divided by 2, that's going to be 30 again. Any way you look at it, you're going to find your constant rate of change, which is going to give you 30 miles per hour for the bear. So here they took and used the change in y over change in x approach. On this one, they just took the and simplified the ratio between the two. 30 over 1 simplified to be 30 over 1. 60 over 2 simplified to be 30 over 1. And for method 3, they took it to 0.1, and at 0.1, as I showed you, the R value, or in this case, is going to be 30. So any way you look at it, that grizzly bear, he travels 30 miles per hour. And that kind of leads to a shirt that I saw in Gatlinburg one time that basically said, what do you do if you attack by a bear? You die. That's pretty much it. I mean, you can't outrun them. You can't outfight them. They're just brutal. So don't play with bears. The rate for the rabbit is greater than the rate for the grizzly bear. Because 35 is greater than 30. So which is going to be faster? That rabbit, at least for a short distance, is going to outrun that bear. And, yep, that pretty well solves that problem. Now it's going to be your turn. Pause this video and work on that problem and see what you can come up with for it. Grace is selling boxes of cookies for a fundraiser. The cost for peanut butter cookies is shown on the graph, where X is the number of boxes and Y is the cost in dollars. The cost of 2 and 8 boxes of chocolate chip cookies is shown in a diagram. Assume that the cost is proportional for the number of boxes of cookies. So here you can see that 1 box was $3.50, 2 boxes is $7, and so on the graph. And on this one, you can see that 2 boxes of cookies were $8, and here 8 boxes of cookies, those are going to be $32. The next thing they want to know is which box of cookies are going to be less expensive. Well, right here, 2 boxes are $7. Right here, 2 boxes are $8. So that means that the peanut butter cookies are going to be cheaper than your chocolate chip cookies. Should point out that this one has a unit rate of $3.50 to 1, while this one has a unit rate of $4 to 1. Check your answer, and it checks. Easy math. For example number 5, we can say the cost Y for computer repairs at Computer Access for X hours is shown on the table. Marco repair charges $23 per hour for computer repairs. Assume the cost is proportional for the number of hours. Which company has the lower cost? Well, if you take and break it down, it's $23.50 for 1 hour. Here it's $50 for 2 hours, also known as $25 for 1 hour, but alas, we need to have some actual math supporting work to justify this. So let's select some buttons here. We're going to say the cost, the change in cost is going to be compared to the change in hours. So you have a change of cost of $25 over the change in hours is going to be 1 hour. We also note this as being the change in Y divided by the change in X. So that means you get $25 per 1 hour for computer access. Scrolling down, it says that as the cost increases by $25, the number of hours increases by 1, so the cost of that one is going to be $25 per hour. Now, if we go to old Marco's repair, or macro repair, excuse me, $23.50 is going to be less than $25, so macro has a cheaper price. But just remember, just because it's cheaper doesn't mean it's a better deal. Extra example 5 is our last problem for this lesson, so go ahead and pause the video and work on it. Mason and Connor are kite surfing at their local beach. The height and Y feet of Mason's kite after X seconds, it can be represented by the equation Y is equal to 3.5 times X. So our slope is going to be 3.5, also known as 3.5 to 1. That's going to be for Mason, so our title that is going to be Mason. Next, the changes in the height of Connor's kite are shown in the table. Assume the height is going to be proportional to the number of seconds. So for Connor's height, I can take and write that one down as just a ratio of any of the pair of numbers. So I can take and compare 8 to 4, which is going to end up giving me a 2/1 ratio. It wants to know the height of which person's kite increases the fastest. Well, Mason's increasing 3.5 feet per second, while Connor is only increasing 2 feet per second. That means that Mason's kite is the one that's actually going to be increasing the fastest. Click over here, check, and the answer is done. Make sure when you're working these problems on your homework, you're giving me good supporting work. I look forward to answering any questions you have in class tomorrow.